Hello, everybody. Welcome to the first virtual Southeast Centre Royal Meteorological Society meeting. New experience for me. I'm presenting from my bedroom so that my children can be downstairs watching the television. So hopefully everyone can appreciate that. And for some of you, it will be your first experience of Demio. So hopefully that goes well for everybody and not just me and our speaker. So today's meeting is going to be Arathi Menon of the University of Reading, but we'll talk about we'll introduce her in a bit. So let's first talk a little bit about the society in our introduction, much as we normally would do if we were in person in the University of Reading. So here we go. So first, remember to join the Weather Club. So we'll have seen slides like this a lot. So if you register to be part of the Weather Club, you get full access to the Weather Club's website, information on events and meetings about weather, such as this one, opportunities to participate in national activities, so the Great British Weather Experiment and competitions and so on, and the quarterly newsletter full of lots of weather news, stories and features and so on. So check out theweatherclub.org.uk. Hello to lots of people I see using the chat and saying hello, so hello. In this case, hello from Reading. I was going to say sunny Reading, but it's not lockdown 1, so it's lockdown 3, so very cloudy and wet Reading. If you're not a member of the of the Royal Meteorological Society yet, you should become a member. So if you are interested or involved in meteorology, and I like to think that since you're here, you are interested or involved in meteorology, then come and join the historic and world-leading Royal Meteorological Society. Well, the membership is worldwide and made up of professionals, academics, students, teachers, enthusiasts and observers. So basically a massive range of people, and you get lots of benefits. So the weather magazine, which I thoroughly enjoy, on the smartphone and apps and online, all delivered to your door. Discounts at conferences and paid meetings, discounts on the other journals that are published by the MetSoc, and access to supports and grants. And if you click on, well, you can't click on that link, but if you follow that link under normal circumstances, you'll be able to sort of learn all about the wonders of membership for the Royal MetSoc. So we're going to have a question and answer session after the talk. I'll let you have a quick, I'll keep an eye on the chat for myself if anybody asks any questions while I present a little bit of a weather summary, which I'm about to do, which much as I normally would do, I'd have sat at the front so those of you who've been to a Southeast Centre meeting in real life would have seen me at the front of the lecture theatre, talk about usually the weather of the last month or the last season or so. I'm going to do the year of 2020 this time. So if I spot a question pop up, I'll try and answer them as we go for that section. Then afterwards, we'll have a separate Q&A session for our main speaker after the event. I should probably say, if you're going to do that, if you want to ask questions, you can ask them as the talk goes on, and we'll flag them up for asking later potentially. But obviously, I can't promise we'll get all of the questions in. Depends how many we get and how time is going. So I thought, since we've had 9 months or nearly 10 months since we had a last Southeast Centre meeting, I should do a weather review of the whole of 2020. 2020, let's say, didn't quite go how we expected it to. But in the weather sense, in many ways, it did go how we were expecting it to globally. So NASA, a couple of weeks ago, I think it was, declared 2020 as the joint, I can't type, look, it says joint warmest year on record globally, which was joint with 2016 and was 1.02 degrees C warmer than the 1951 to 1980 baseline. The other agencies around, so Hadley Centre, NOAA and Barclay Earth, all don't quite agree with the exact numbers and exactly whether it was the warmest or joint warmest, etc. But you can see the plot I've shown here of the temperature anomaly through time, and you can see that 2020 was probably the second hottest on all of those temperature records, if not the hottest. What's probably the most worrying in a sense, to the biggest sort of sign of global warming, the last 7 years have been the warmest 7 years on record, and typifying the ongoing and dramatic warming trend, which Gavin Schmidt, the GISS director, said, which was part of the big NASA press release. So that's globally another as we would really expect these days, another very warm year. For the UK as a whole, 2020 was also quite warm. So this is the mean daily maximum temperature. And you can see the brown dark line is the value for the most recent year, so 2020. And it's very warm. It's not the highest. I think it's fourth. It might be fifth on the chart. It's still very warm and continuing that trend of warm years. For maximum, I move on to the mean minima, and it's not quite as much as excessive as extra warm. Let's try and put that in a nice way, but again warm, and you can see the warming trend so clearly in these plots. The rainfall amount for the year, there's obviously much less of a trend in this, but 2020 was actually quite wet, really, just over 1,300 millimeters over the UK. So quite wet, but there's that one interesting, really, to be quite wet, because as we move on to the next slide, we see the sunshine hours, and it was also quite sunny this year. So we've had now 3 years in a row that were sunnier than average, which starting to seem a little surprising. Hopefully anybody in the UK will have noticed just how sunny spring was in particular, and we'll see that in a moment. So these are the maps for the 2020 year over the UK, and you can sort of see the left is the mean temperature, middle is rainfall, right is sunshine, and these are anomalies on the 1981 to 2010 averages. So temperature was particularly warm, more than a degree warm in the southeast, and basically between 0.5 and 1 degree pretty much everywhere else. The rainfall, interesting, sort of west to east. West is particularly wet, and the east is about average, really. But the sunshine, it's particularly clear, really. The southeast was very sunny, and you can see, like, us in Reading are going to be in that yellow above 125%. And so I'll quickly just have a look at 2020 at the University of Reading Observatory. I like the University of Reading Observatory because it's easy for me to look these numbers up because I have my own website that looks at them. And so the University of Reading Observatory 2020 average values here. So our temperature anomaly was plus 1.44 degrees C for the daily maxima, and only 0.65 for the daily minima. So warm days, not quite so much warm in the night, but that was a 1.02 degrees warmer than average. So interesting to note this year, 2020, that we were warmer than average for Reading on our 1980 to 2010 average, exactly the same amount as the globe was compared to the 51 to 80 average. So interesting quirk of statistics. I guess what's in a sense going to be worrying is next year, if I give you the same numbers, that anomaly wouldn't be quite so big. And that's because next year we'll be using the 1991 to 2020 averages, and so they're a bit warmer. And so all the anomalies are going to effectively go down. So just be aware of that when you're thinking, oh, we've had so many recently plus 1 degree years. Wonder why this one's only not quite so big. Well, the answer is because the averages are going to change. But there we are. You saw we had 125% on the Met Office's chart. We've got 24% extra sunshine according to the Reading sunshine measurement, but 18% extra rainfall as well, which I think was interesting. It was both wetter and sunnier. And I've just pulled out a few of the records from Reading, so of our 65 years of sunshine records, and back to 1908 for the temperatures and rainfall. So it was very comfortably the second sunniest year on our record. That goes back it goes back to 65 years. I'm pretty sure it was 1959. Simon can comment in the chat that I'm wrong. I think it was 1959 that was the previous record holder of the sunniest year. For a little while, sort of mid-November, we were thinking we could beat it, but December rather put pay to the end to any real chance of doing that. But we did have the sunniest April on record with over 250 hours, which was then promptly followed by both the sunniest and the driest May on record. And so the driest May goes back to 1908 record. We only had 1 millimeter of rain in May. amazing. So while we were all trapped at home in lockdown in April and May, the weather was fabulous. Yeah, Simon has said in the chat that he thinks I was right on the year, but the sunshine measurements are probably the most uncertain, and I certainly agree with him. There are numerous issues with sunshine recording, and potentially for our own recording at the University of Reading site too. So probably not brilliant. So May, having been, as it was sunny, it was dry, and it also had the highest May T max since 1922. So almost 100-year record for daily maximum temperatures in May. So it really was fabulous month, May was. And then just to get the proper autumn misery going, we had the wettest October since 1960 in Reading. So I'll give you a few seconds to somebody to type any interesting question. Simon has pointed out, rather than the question, Simon's also pointed out that May was the sunniest of any month, which, yeah, I don't think I did say. It was true. So it's somewhat surprising that May would beat it. And we have a comment that's surprised that February wasn't the wettest on record. The February wasn't that special. I think February's particularly February's can be can be very, very wet. So I think it was 2014 that February was incredibly wet. So that's my weather summary. We should move on to Arathi's talk now. So we'll bring up her title slide and I shall introduce Arathi. I need to just hide myself. Turn off my camera. Dr. Arathi Menon is currently works as a research scientist at the University of Reading. Her current research focuses on understanding processes affecting the progression of the Indian monsoon, including the effect of dry air intrusions and land surface processes, using observations and high-resolution model simulations. She holds a PhD in climate physics from Potsdam Institute of Climate Impact Research in Germany, and her previous experience includes study of changes in the monsoon, rainfall under global warming, tropospheric and the tropospheric biennial oscillation. I can see Arathi smiling happily at my inability to say words properly. So on that note, I'll pass over so that I can stop embarrassing myself. Arathi.
The nice introduction. So I will start with my talk. Good evening all. As you know, I will be talking about the seasonal forecasting of the Indian monsoon and the Indian Ocean tropical cyclones of last year. Firstly, let's see why is it important to forecast the Indian monsoon, or why is it important to study the Indian monsoon? India receives around 80% of the annual rainfall during the monsoon season from June to September. So just these 4 months. If you look at the picture in the background, that's how a typical monsoon day usually look like. So if we compare the monsoon rainfall with the rainfall that we receive in the UK, we can say that the rainfall amounts are similar, but in the UK, this much amount of rainfall is spread over the year. But in India, this much amount of rainfall is received just in 4 months. So they are usually like heavy showers rather than drizzles. And around 1.3 billion people living in India and the surrounding countries. Like India, such a country like India with just 1/3 the size of the US, that's a huge population. And these people depends upon the monsoon rainfall for their basic water needs and also for agriculture. And out of this population, around 20% of the people live below the poverty line. So the impacts the deficient rainfall or like extreme events can have on these people is much more. Around 66% of the agriculture in India is rain-fed, and agriculture is one of the major industries in India. And this rain-fed agriculture contributes to around 18% of India's GDP. So any variability in the timing and intensity of the monsoon rains can have huge impact on the lives of the people as well as the economy. Yeah. If you look at this figure on the left, I can't use a pointer, so I will just try to point out. This figure on the left, the red and blue graph, that shows the rainfall and rice harvest from over predominantly rain-fed rice growing states of India. So here the red line shows the monsoon rainfall and the blue line shows the rice harvest. And we can see that these two are like highly correlated. For example, if you look at the year 1979, which is a dip in this graph. So the rainfall was quite deficient during that year. And you can see that the rice harvest is also quite low during that year. Then in 1980, when the rainfall is higher, or the rice cultivation, the rice harvest also improves in 1980. So these two are highly correlated. If you look at the photo in this slide, that shows a paddy field in India. So usually for the rice paddy cultivation, you need these kind of waterlogged fields. And this water is usually, this is obtained during the monsoon season from the monsoon rains. And if you look at this graph again, we can see that there is large year-to-year variability in monsoon. So this figure shows the monsoon rainfall anomalies from 1961 to 1999, maybe. So you can see that, like, for example, in 1979, the monsoon rainfall was quite low, but in 1980, that is quite high, or like slightly higher. So there is a large year-to-year variability in the monsoon rains. And hence, predicting the monsoon in advance is quite vital. So even though the monsoon comes every year during the summer season, there is large variability in the amount of rainfall received, and there is also large spatial variability where the rainfall is concentrated, like which all regions receive more rainfall and which all regions receive less rainfall. And the agricultural planning depends upon all these forecasts. Now let's quickly go through the basic dynamics of the monsoon. So why does monsoon occur every year in South Asia? So if you look at this figure, suppose that the left side of the figure is south and the right side is north. And the green mass you see there is the Indian land. And you can see this elevated region towards the north, which is the Tibetan plateau. So during summer season, the land gets heated up much faster than the ocean. So there is also this elevated Tibetan plateau near India. So this Tibetan plateau and the land gets heated up much faster than the ocean because of the difference in the specific heat capacity of the ocean and the land. As a result, a low pressure develops over the land and a high pressure develops over the ocean. This results in winds moving from the high pressure region to the low pressure region, that is from the ocean towards the land. This actually starts the monsoon. This is the basic mechanism that starts the monsoon. But once the monsoon circulation starts, then there will be a lot of rainfall and cloud formation, and this latent heat release from these clouds, they will help to sustain the monsoon. This is again shown in this slide. So this figure shows the near surface winds, the winds at 925 hectopascal during winter. The top panel is for winter and the bottom panel is for summer. So if you look at the encircled region near India, we can see that over the Indian Ocean, during winter, the winds are easterlies. So they are the northeasterly trade winds. But if during summer, if you look at the figure in the bottom, we can see that the winds have reversed their direction. So as I mentioned in the previous slide, the land and Tibetan plateau starts getting heated up, and this results in a reversal of the wind. So then it becomes like a huge sea breeze. That's how it looks like. So this shows the reversal of the wind during the monsoon season that helps to start the monsoon. Now, as I said, there is large variability between the rainfall from year to year. So I'm showing here the monsoon rainfall for some years like 2002, 2016, 2018, and 2019. So here, each bar, for example, if you look at the first panel for 2002, each bar here shows the rainfall averaged over India from 1st June to 30th September. So each bar shows the rainfall averaged over the entire country during the monsoon season. And the red line here shows the climatology, or like the normal value that is obtained by averaging the values for several years. So the normal value is shown by the red line. Here I have encircled the July rainfall, which is shown by this green circle here. You can see that in July, the rainfall was much lower than normal. So for the entire July, there was like very less rainfall, or there was a rainfall deficit over the country as a whole. As a result, 2002 was a really bad drought year. If you compare it with 2016, which is the second panel, again, the July rainfall is encircled. And we can see that for most of the days in July, the rainfall was above normal for the whole of the country. So this changes a lot from year to year. Similarly, if you look at 2019, which is the bottom panel, the last one, if you look towards the September, in September, we can see that almost every day the rainfall was above normal. But that is entirely different from the other 3 years, which is shown here. So there is a large year-to-year variability that needs to be understood, or that has to be forecasted. And also within a season, for example, if you look at 2002, as I said, the rainfall was really deficit in July. But if you look at June, August, and September, the rainfall was close to normal. So within a season itself, there is large variability. So the monsoon rainfall has large interannual variability as well as intra-seasonal variability within a season also. So all these has to be understood and forecasted if you want to do agricultural planning. These are some pictures from 2002. As I said, 2002 was a drought year because the entire July had deficit rains. So this was a really bad year for India. And you can see the photos of like how the crop lands were on that year. This resulted in lots of like death of many people, and people had to walk like miles and miles to get some water, like drinking water. And another sad thing is that like many farmers, like since all the crops failed, a lot of farmers went into debts, and many farmers committed suicide during that year. So all these kind of so some years are drought years, and then all these kind of pathetic situation happens. Then now I'm showing an example of another extreme. During 2018, there was a huge flood in a state called Kerala. Kerala is a state in the southwest of India. That is where the monsoon onset takes place. So usually the monsoon first reaches India at Kerala, and then it spreads to the northern parts of India. And 2018, August, Kerala had the worst flood of the century. So like in the past 100 years, there were no floods that have, like Kerala never witnessed any floods in the past 100 years. But in 2018, there was a huge flood. Like a lot of people died in that flood. And since like nobody had experience with like witnessing a flood before, it was really tricky to do the rescue operations. Like everyone just had theoretical knowledge, and it was really tough to put that into practice. So you can see like the bottom right picture in which the army was deployed to rescue people, and then the top middle picture you can see that's the Air Force rescuing people from the flood areas. So within the monsoon, these kind of extreme events happens. Some years, like there will be drastic flood leading to crop failure, and it affects the economy and the people. Some years there are like large floods that again affect these billions of people there. Now coming to forecasting the monsoon. The monsoon forecast also has several limitations. So if you look at this left figure, which says like CMIP 5 MMM minus GPCP, that figure shows the rainfall biases in the CMIP 5 multimodal mean compared to the GPCP satellite observations. So CMIP 5 models are the models that participated in the IPCC AR5 simulations report. So if you look at the figure, in the central India, you can see these bluish green colors that shows a dry bias. So there is a dry bias in rainfall over India. And if you look at the tropical Indian Ocean, Arabian Sea, you can see this red orange colors, which shows a wet bias. So generally, the CMIP models have quite a dry bias over India and a wet bias over the tropical Indian Ocean, and this could affect the forecast. The figure on the right shows a comparison between the biases in CMIP 5 multimodal means and CMIP 6 multimodal means. So CMIP 6 are the most recent IPCC AR6 models. So even in the most recent models, you can see that the dry bias exists over India. In this right panel figure, the red colors show dry bias. So they are lighter in the CMIP 6 bias. So the bias is slightly better in the CMIP 6 models, but still the bias exists. So forecasting the monsoon is mainly limited by inadequate representation of subgrid scale or like small scale processes. And we also don't have enough observations to understand these processes in detail. So there are several Indo-UK collaborative projects, like from the from many years. UK is like really interested in improving the forecast. So like all over the world, this is like the monsoon circulation is a large circulation, and centers from around the world is interested in improving the monsoon forecast, which can affect like the entire globe in different ways. So there are several Indo-UK collaborative projects that try to improve the monsoon forecasting skills. And one such project is called Encompass Project, of which I was a part of. So that is a joint project between the UK's Natural Environment Research Council and the Indian Ministry of Earth Science. So as a part of the project, we did a field campaign in India during the monsoon season of 2016. So the UK's atmospheric research aircraft, FAM, was deployed in India during the 2016 monsoon. And if you look at the left figure, you can see many lines over the India map that shows the route of the flight. So we did all these measurements to collect atmospheric, like the monsoon data from the aircraft. And we also had several land-based stations. And for example, if you look at the bottom right figure, you can see that's a flux tower. There were several flux towers installed in different parts of India, and there were also like radio sound observations. So we have this huge data from the monsoon season of 2016, and we are analyzing these data to understand the basic or like the small scale monsoon processes in detail. And then we are also doing high resolution model simulations to understand these processes, which will eventually lead to the betterment of the models. Now coming to the seasonal forecast of the monsoon, the India Met Department uses two forecast systems to give the monsoon forecast. One is a statistical ensemble forecasting system, which considers the relationship between, for example, the May temperature over Eurasia or the May sea surface temperature over the Atlantic. Like that, they have 6 predictors, which is used to predict the monsoon of June, July, August, September. And the India Met Department also uses a dynamical coupled ocean atmosphere forecasting system, which is a US model, the NCEP CFS model. So using these two, this statistical and dynamical model, the India Met Department issues monsoon forecasts every year. If you look at the table on the left, so the operational long range forecast, the first operational forecast for a monsoon season is issued in April. So around like 2 months before the monsoon, the India Met Department gives a forecast for the monsoon. And usually they forecast the June to September rainfall, and for the country as a whole, which is given like the all India rainfall will be above normal or below normal, like that. Such a forecast is given in April. Then in June, an updated forecast is issued by the IMD. So usually like by June, the monsoon onset takes place and a forecast is given. And that June forecast usually update the April forecast. So the June forecast is based on the May initial conditions or the May atmospheric conditions, and that is used to update the April forecast. And in June, the forecast is not only for the entire country, but a forecast is also issued for different geographical regions, which is shown in the bottom India map. It shows like 4 geographic regions over India. So separate forecasts are also issued for these different geographic regions. Then a third forecast is given in July, midway through the monsoon, to forecast about the second half of the monsoon. And another forecast is given in August to forecast the withdrawal of the monsoon. And also, in addition to that, the India Met Department forecasts the onset date of the monsoon. So climatologically, the monsoon onset takes place on the 1st of June. So it's 1st of June that the monsoon onset takes place over Kerala. After that, the monsoon progresses in the country towards the northwest of the country and covers the entire country by around mid-July. So during April, this onset forecast is also issued, like what date monsoon onset will take place on that particular year. And this picture on the left, that shows the first stage forecast that was issued in 2020. So now we will look at the forecast for the year 2020. This forecast was issued on the 15th of April 2020, that you can see at the top of that press release. And the monsoon, based on the April conditions, the monsoon was forecasted to be normal for the year 2020. And the monsoon onset date was forecasted to be 5th of June. The monsoon onset date can also vary a lot. Sometimes it happens like on the last week of May, or sometimes it could even move to like the 3rd week of May. And sometimes the monsoon onset is delayed. It happens only like the 2nd week of June. So there is a large variability in the onset date also, and that is also forecasted. So it was forecasted to be 5th of June for 2020. Then this press release here shows the second stage forecast, which was issued on 1st June. Again, you can see the date on the top. And even like on the June forecast, this was very similar to the first stage forecast, and a normal monsoon was forecasted. And now let's see what actually happened in 2020. So the figure on the left, the map on the left that says actual, that shows the rainfall that occurred from 1st June to 30th September 2020 over these regions in India. So that is the rainfall accumulated, added together from the 1st of June to 30th of September during the monsoon season. And this is from observations. So this is what actually happened. And the figure, the second panel, the second map shows the normal rainfall, that is the climatology. Then the third panel shows the percentage departure from normal. So if we look at the third map, it shows that the western parts of India, like Gujarat, which is shown in that blue color, and the southern parts of peninsular India, so all these blue areas received above normal rainfall, around 30% above normal. And if you look at northern parts of India near Jammu and Kashmir, you can see that red color. So that shows a deficit, rainfall deficit. It was around like 30%. Uh, that region received around 30% less rainfall. So some places received above normal rainfall, some places received below normal rainfall. But if you consider the country as a whole, if you average the rainfall over the entire country, then you get this time series on the right, which is similar to the figures I showed for 2002 and all. So here these bars again shows the rainfall from 1st June to 30th September. And the red line shows the climatology or the normal values. And we can see that if you add all these values of the black bars, the actual rainfall was around 957.6 millimeters. And normal rainfall is 880.6 millimeters. So there is plus 8.74% departure from the mean. So the rainfall was slightly above normal. But if you consider the interannual standard deviation, the variability from year to year, the interannual standard deviation is 10%. And this percentage departure, which is 8.74%, is still within that interannual standard deviation. And hence, this was a normal monsoon. Now, this is the forecast issued by the India Met Department for the 2020 monsoon. So the figure on the left shows the rainfall, like probability forecast, like which all regions have probability of getting above normal rainfall and which all regions have probability of getting below normal rainfall. So you can see that the western parts of India and most of South India was forecasted to receive above normal rainfall. This forecast was given in April based on the April initial conditions for the June, July, August rains. And the northern part of India was forecasted to receive below normal rainfall. And from the actual observations, we saw that that was the case. The figure on the right again shows the forecast by the India Met Department. And this actually shows the actual values or like the anomalies. So the western side of India, which is in deep blue in the second panel, right panel, they were they were forecasted to receive around 2 to 3 millimeters per day more rain. And the northern part and the east of India were forecasted to receive slightly below normal rainfall. Now, this figure shows the seasonal forecast from different models from different centers around the world. So if you look at the second panel, that shows the monsoon rainfall forecast by the ECMWF model, which is the European Center for Medium Range Weather Forecast, which is also located in Reading. So this is the second panel is the forecast from the ECMWF model. And all these forecasts were issued based on the May initial conditions. And we can see that it shows light green colors towards the west of India and the south of India, which shows slightly above normal if you look at the color bar in the bottom of the figure. So the ECMWF model forecasted slightly above normal rainfall towards the west of India. And the third panel on the top, which says UK, that is the forecast from the UK Met Office model. That also shows these light green colors, which means like slightly above normal rainfall. Then some models show like high values, like for example, the Australian model. But the first panel in this figure, which says multimodal ensemble, that shows the mean from all these model ensembles. And the multimodal ensemble again showed light green values all over India, which shows slightly above rainfall. So altogether, the India Met Department's operational forecasts, as well as the multimodal ensemble from the models from all around the world, they all forecasted a normal monsoon. And it was a normal monsoon. So this last year, the forecasts were quite good. And the onset date was forecasted to be 5th of June, but the actual onset was on the 1st of June. So, but it still falls within the plus or minus 4 days of model error. So that was also kind of good. Now let's move on to the two major cyclones of 2020. So there were many cyclones, like small cyclones over the Indian Ocean during 2020. But I'm just talking about these two cyclones which were like very severe. One was a super cyclone Ampun, the one in the right. So you can see the track of what is shown here is the track of the cyclone. So that cyclone was there in May 2020. It formed over the Bay of Bengal and then made landfall to India. Then in June, there was a severe cyclone called Nisarga that also made landfall on India. Now let's discuss about the super cyclone in May, which is called, it's actually written as Amphan, but I read somewhere it's pronounced as Ampun. This cyclone was there from 16 to 21st of May. If you look at the left side figure, that shows here the black line on this left map, that shows the observed track of Ampun. So the Ampun formed over the Bay of Bengal and finally made landfall on the 20th of May and then got dissipated on 21st of May. And the figure on the right shows the forecasted track from the India Met Department. So the red line here in the right side map, the red line shows the forecasted track. So if you compare the black line on the left-hand side figure and the red line on the right-hand side figure, they look very similar. So this forecast was given on 17th of May, and in the forecast it shows that the cyclone will make landfall on the 20th of May. If you look at where it made landfall in the map, the forecast showed that it will make landfall over West Bengal, and that's what the observed track also shows. So this was one of the strongest Bay of Bengal tropical cyclones after the Orissa tropical super cyclone in 1999 October. So this was a very after the Orissa super cyclone in 1999, this was the first cyclone of similar intensity that occurred in the Bay of Bengal after so many years. And the wind speed of the cyclone while it made landfall was between 155 to 165 kilometers per hour. And this was one of the costliest cyclones that happened in Bay of Bengal. It caused a damage of around 13 billion US dollars. This slide shows the tropical cyclone track and intensity forecast from 3 other models. The first one is from the ECMWF model. Second one is from the GFS model. And the third one is from the UK Met Office model. So here different lines show the track from different ensemble members. So, and the black line shows the ensemble mean, or like the mean track. So if you look at these black tracks from the 3 different models, we can see that all of them showed a landfall of this cyclone near West Bengal. And if you look at those colors in those individual lines, those colors represent the wind speed, maximum wind speed, and they are mostly like this red and orange, red, pink when it was making landfall. So that means like the wind intensity was forecasted to be between 60 to 80 knots, which is close to around 150 kilometers per hour. So these forecasts were all good. Now, I would like to play a video to compare the forecast and the observations. Thank you, Eleanor. Yeah. So you can, if you look at this right side figure, that shows the satellite image of the cyclone making landfall. And you can see like the time can be seen from the top right of the right side figure. So you can see that it makes landfall on 20th of May at around 9 o'clock. This I makes landfall, the pink color, center of the cyclone makes landfall on around 20th of May at around 9 UTC. The left side shows the track from the forecast, that is from the GFS forecast. There also, like in the top right, you can see the time. And if you look at those closed isobars in that inside that green color, which shows the center of the cyclone, it makes landfall on 20th of May at around 9 UTC. So both these cases, like if you compare the satellite observations with the model, it shows like very similar track, almost exact time of landfall. And it also like the location of landfall is also very exact. So this was one of the best simulated or like forecasted cyclone. So this forecast for this cyclone was quite good. Yeah, these are some of the pictures showing the destruction from Ampun. There were a lot of floods and many people lost their properties. There was huge damage to infrastructure. But if you compare this cyclone Ampun with the previous super cyclone, which was the Orissa super cyclone in 1999, the fatality rates were like quite low in this one. So in Ampun, around 90 people died, but in the Orissa cyclone, super cyclone, around 15,000 people died. So firstly, like the tropical cyclone forecasts have improved a lot over the years. So the track and the landfall timing, all those forecasts were quite good for this tropical cyclone. And another thing is that the government policies or evacuation measures have also like improved. So a lot of life could be, so many lives could be saved due to all these. The figure, the photo on the top right, photo on the bottom right shows people in the relief camps. So lot of people were moved to the evacuated to the relief camps. It must be really hard to go to relief camp amidst this pandemic, but at least like many lives were saved. Now I will quickly go through the second major cyclone, which is the severe cyclone Nisarga. That occurred, formed in the Arabian Sea in June 2020. Now the figure on the left shows the observed track of that cyclone, and the figure on the right shows here the red line in the right side figure shows the forecasted track. We can see that the observed track and the forecasted track are very similar. This severe cyclone Nisarga made landfall on the 3rd of June. When it made landfall, the wind speed was around 140 kilometers per hour, and the fatality rate was less. 6 people died in this. And it resulted in a damage of around 803 million US dollars. But this was one of the worst cyclones to hit the west coast of India. Compared to Bay of Bengal, not that many cyclones form in the Arabian Sea. And usually when they form over the Arabian Sea, most of the cyclones move towards the Gulf region. And only like rarely they move towards the Indian land. Again, these are the forecasts of the track and intensity from 3 different models. The forecast I showed in the previous slide was from the India Met Department. Now, this here, the left panel is from the ECMWF model, middle one is from the GFS, and the right one is from the UK Met Office model. So all these models like captured the tracks quite well. Track and the intensity was captured quite well by most of these models. This is a satellite picture of Nisarga when it is hitting the land. You can see the eye of the cyclone like that circle in the middle hitting the land. And these are some of the pictures that shows the destruction from Nisarga. Lot of like uprooted trees, and this also caused like large damage to infrastructure, even though like the lives of many people could be saved. It was accompanied with heavy rains and rough seas. You can see all those pictures here. Yeah, so to summarize, 2020 was a normal monsoon year for the country as a whole. And the seasonal forecast by the India Met Department and also by models from other centers, they all forecasted a normal monsoon last year, and that's what happened. And there were several extreme events like floods associated with these cyclones, super cyclone and severe cyclone. And the track and intensity forecast of the cyclones were quite good, which helped to save the lives of many people. Yeah, that's it. Thank you.
Question now becomes which question I pick. So I think I'm going to stick to. I'll go to one that sort of I think is quite relevant throughout, really, and it was a question I was going to ask. So well done. So click that and answer live. So even if the forecasts of the monsoon rainfall, and I guess the same applies really to the sort of tropical storms and cyclones and super cyclones and so on, even if they're absolutely perfect forecasts, would the sort of small scale farmers that India has a huge numbers of be able to modify their farming strategy in a way that would actually realistically help?
Yeah, it's like that is the biggest problem. Like even though this large scale forecast for the entire country is good, the farmers still have all these troubles. That's why like all these that's why still all these research are going into improving these forecasts. It's like recently there are in many places I heard that the farmers are getting text and all. Like if you have a mobile phone, then you get a text regarding the weather for the next few days or so. But they only like small changes can be done in like you can get the forecast not in a long range, or like you don't get a forecast for small regions much in advance so that they can prepare the farming, but it is much better compared to previous decades maybe. But still yeah, the farmers would need more localized forecast. But still if you can for example, like in 2002, if you can forecast that it's going to be a huge drought for the entire country, those kind of forecasts can help. Then at least they know, like they don't have to waste the crop, or so that they know that will fail. But still their economic status is so poor that they can't do anything about it much.
Yeah, I think the same problem will apply to a lot of forecasting of any kind of event, even not in poor people.
Mm.
Even in the UK with the flash flooding I talked about a year ago, even if you could give the perfect forecast, doesn't mean you can prevent these incidents. So
Yeah,
the ability to forecast it doesn't necessarily mean you can do a great deal about it.
yeah.
Right, let's go next. The next, I'm going to have a couple of questions that are sort of similar in a sense. I'll go for this one first.
Mm.
So Matthew Nuss. So do the IMD issue seasonal cyclone outlooks or monsoon wind strength outlooks and so on for the Arabian Sea or the Bay of Bengal, much as like we issue, or the Americans particularly issue warnings, sort of outlooks for the Atlantic and so on.
Actually, the India Met Department has a web page dedicated to that gives these cyclone warnings. So I don't think it's like seasonal outlook, like a season in advance or like
Yes.
much in advance. But usually, like closer to the time, the IMD has a cyclone monitoring page. So if you look at that, it will show the outlook of the cyclones. And then there are like press releases. Once the monsoon starts, during that time, there are many press releases from the India Met Department.
But they're not quite in the sort of the same way we get with the Atlantic, where they'll predict there'll be this season will have 20 named storms, of which 3 will be Category 5 or similar sorts of predictions.
Yeah, I don't think
okay, so I'll go for, so the next sort of one was a similar one, which is which was by Gerald. So do the IMD use a mean of various models when doing cyclone forecasting in the same way they do for monsoon forecasting? So yep, I know that they do monsoon forecasting by looking at numerous models.
Yeah.
Do they do the same thing for cyclones?
I am not sure about that. I think it's usually the IMD model. The IMD's forecast is based on the IMD models, I think. Also, like, so as I said, the IMD uses mainly the NCEP GFS model. At the same time, the National Center for Medium Range Weather Forecast in India, they use the a version of the UK Met Office model. So they also produce operational forecasts, which is sometimes like they are also associated with the IMD. So I think IMD also takes into consideration their forecast. But other than that, I don't know if there are any other models.
Right, so let's go for, we've had several sort of all worded slightly differently. I've picked this one by D, but really there's quite a few questions that were pretty similar. So basically, the questions, I'm going to just boil down slight versions, because on both of those storms, they went largely north or north-northeast of the 2 cyclones.
Yeah.
Basically, the questions are why in both cases. So the same, almost identical questions came up on both storms. So I've kind of asked them both at once.
Yeah. Yeah, I know. Actually, I don't know why that one, what atmospheric condition during that time resulted in this northward track of the tropical cyclone. I don't know. Sorry.
Because that's not the normal direction, is it really?
Yeah. It's normally like westward.
Yeah. So that, scrolling through my page. So, well, I've got one question here. I'll click it because it will mark it as answering. Was what was the role of the large scale flow in this cyclone? Presumably that will be partly why it took the unusual path.
Maybe, yeah. But
I imagine that will be
maybe that has a role. I'm not so sure, because usually I don't know like what time the other cyclones that move towards the west occur. Because what happens is during the monsoon season, first of all, once the monsoon is like fully established, you don't get many tropical cyclones. You get many lows and depressions, but they can't intensify into a cyclone because you have these strong monsoon currents, and then you have like easterly currents in the upper atmosphere. So you have this large wind shear. So usually you don't get severe cyclones, because both these cyclones also, one was formed in May and the other one was formed during, Nisarga was formed during the beginning of June. So that's when just the monsoon just started. But still the southwesterly winds would have been already established. So that might have a role in like moving that cyclone towards India. But maybe the other cyclones that usually form over the Arabian Sea, they might be forming like before pre-monsoon or like post-monsoon. Maybe then they don't have these strong winds to steer them to India. Yeah, that might be.
So given that one, I'm picking questions really more to try and follow a trend. I'll go for Peter Gibbs's question. So, so his was basically almost. So you mentioned shear and like that. Basically, they can't really form very well with the shear. Is there evidence that the cyclone season in Arabian Sea and Bay of Bengal are starting earlier as sea surface temperatures rise through global warming?
Yeah, I know that their intensities and frequencies are increasing, but I'm not aware of like the time of their formation. I don't know if they are occurring earlier, but their intensities and frequencies are increasing under global warming as per many studies. But I don't know. Sorry, yeah.
So I'm going to head now in that direction from the questions. So there's what ends up being a selection of questions that got marked as questions, but really they basically are: do all the stats of the monsoon and I guess the cyclones as well, do they show any useful link with El Nino? So does knowledge of El Nino, would that help with predicting the monsoon?
Yeah, definitely. So they also consider like for the statistical forecast, that also considers the El Nino condition. So usually when there is an El Nino, it is supposed to suppress the monsoon rainfall because you get like down drafts over India when you have El Nino. And you get like monsoon is above normal when you have La Nina conditions. So that definitely goes into the forecast. But then still it's then it gets more complicated. Like some studies show that the effect of Central Pacific El Nino compared to the East Pacific El Nino is different over India. So, but yeah, so all those kind of complexities are there, but still El Nino goes into the conditions of El Nino goes into the forecast. And also like other large scale circulations or like oscillations like MJO, that also affects the monsoon forecast. Yeah.
Okay, well, I'm going to go for I'll go for a more recent question just because it feels like it should go. How do you think the improvement? How do you think for the sort of? I guess how do you think for the improvement of the monsoon forecast? Where do you think improvements are going to come? Do you think, for instance, better prediction of the El Nino conditions would make big differences? For instance,
as I mentioned in the like the introduction part, I think the main improvement is needed in like understanding the subgrid scale processes. So usually the effect of the large scale processes are quite well known. And for those large scale processes, it's compared to those large scale processes, I think more emphasis should be given to the subgrid scale processes. And if we can improve the understanding of them, then that will eventually lead to the better forecasts.
cool. Right, I'm going to go for a couple of what I'm going to describe as nitty-gritty questions now. There were ones that came up as you were talking. So the first one is on your forecast limitation slide, which I think was slide 10. I was trying to keep a note when people ask questions. So it's probably either 9 or 10. Yeah. So the question, let's hit my button. The question is on this slide, what are the size of the grid that these, yeah, it's maybe it's before this. It was definitely before slide 11. Yeah. It's probably this one here.
Yeah, this one. These size of these grids, these are usually like all these CMIP5 models are 2 degrees to 2.5 degrees resolution. So that's mostly like 2 to 2.5 degrees is the grid size.
Okay. And then the next one, which was a few slides later, basically, where the question was, what time span is the climatology calculated over? I guess I should have been well awake and asked this question as well. I should be ready for this question, given I talked about the fact that when I present these things this year, I'm likely to be using a new climatology for Reading. So.
Yeah, exactly. So like in the map I showed for 2002, maybe. So until like last year, the climatology was used, I think from 1940 to 2003 or something. I don't exactly remember the years, but they were like quite or even before 1940, but I'm not so sure. But those were the years used in the climatology, which was up to maybe 2000 or something like that. But last year, the India Met Department redefined this climatology. So in 2020, they started using a new climatology, which now also include the recent years up to 2018 or something like that. So that takes into consideration all these recent trends in monsoon rains. Yeah.
Right. So I think I think I've answered most of the questions that have come up that either directly or have sort of been very related. But we have this one, which is Aaron. Aaron has asked has the relationship between pre-monsoon cyclones and monsoon onset been studied? Maybe this is waiting for for a project desperately waiting to be made, or maybe you already know it has been.
Yeah. I don't know of studies that looked at this, but that's a good point. Usually, over the Arabian Sea before the beginning of the monsoons, sometimes, like, not every year, but a vortex forms over the Arabian Sea, which is called as an onset vortex. So there are many studies that look at the effect of this onset vortex and the onset of the monsoon. But I'm not sure if there are studies that look at the pre-monsoon cyclones and the onset of the monsoon. Maybe it might have some role in providing energy, but I'm not sure. It's usually this temperature gradient and pressure gradient which is thought to be mainly driving the onset.
Well, it sounds like perhaps there's a whole study to be done there waiting to happen.
Yeah.
Always nice when that comes up. So I jumped into Aaron's question before I gave Dee the chance because she quickly came back and asked again. She asked, does this still include the early data? So I guess that was, do your climatologies include early data? Presumably.
Yeah.
Yes, it does.
It still includes early data.
I'm just scrolling through to check that. I think we've covered most of the questions, all of the questions here. Yeah, position. So we had a question on the position of the jet stream, not really changing. I think you've sort of answered that one. So I shall that one, and I shall start bringing the meeting to a close. I should say now that we've had our first Royal Southeast Area meeting for some months now. So it will be so I should tell you that we have got intentions to continue having more Southeast area meetings now and go monthly, but obviously they're going to remain virtual meetings for the time being. So on what I believe should be the 2nd of March, keep an eye on your social medias. We're going to hopefully have 2 PhD students from the University of Reading speaking about their work they're doing. Normally we have this talk, we've had this annually for the last several years, normally in the autumn, but we're going to try and get this one in the spring. So one of those 2 speakers is almost certainly going to be fellow committee member for the Southeast area organising our talks, Simon Lee, and hopefully we'll have another one of the prize winners from our Quo Vadis session. So get to find out what the students of the University of Reading are doing. Then in April, so the first Tuesday of April, we'll have Mark McCarthy. We've not got an exact title from Mark, but from the Met Office. And then on early May, we'll have Ben Pickering, who is a radar and distrometer expert from the University of Leeds, I believe. I suddenly worry that he may have moved. However, I believe so. And I don't think he's here, so I'm not going to get in too much trouble. Then we've got some more upcoming talks from not the Southeast area, but for other virtual meetings. So virtual meetings are the way of the Royal Met Sox these days, as the rest of the world. So on the 11th of February, so what's that, in a week and a couple of days, we've got Midgard Viking Expedition, the Search for Intelligent Life on Earth, by Bjorn. I can't pronounce that name, so I'm not going to try. I will get myself into trouble. And then Postgraduate Showcase on the 19th of February, on the evening of that Friday, where we're going to have University of Leeds and University of Reading speakers for the Postgraduate Showcase. So come and come and see those. Stay and see those. The wonders of virtual meeting. So with that, I shall bring the session to a close.